Guys, at the top of the page, I'm just going to give you a quick reminder. All right? Domain. We already said this. You don't really have to rewrite this part. Domains are X values. I'm going to give you a super simple way of finding this from the graph without having to do any fancy math, anything. All you have to do is, if you'll just ask yourself when you're doing domain, how far left, how far right. Guys, that cheat code right there, let's just do domain for a second. I'll come back to range. Guys, I'm going to be asking your groups to participate here while we're discussing this. I'm going to zoom in because I know. All right. When you're doing domain, we're talking about which axis, X or Y?
X.
Domain's your X. So look, while we're talking domain, I like to go ahead and label infinity, negative infinity on the X-axis. Sometimes we'll need infinity and negative infinity. Let me see, I'm going to start up here with Jameson's group. This is the first one we've tried together. All right. Let me just ask a question that seems to be a little weird to everybody. How many ordered pairs do y'all see on that circle?
Infinity. I guess it's
For everybody in here, guys, let's go ahead and wrap our mind around this. I realize that that earlier today, some people were just saying these 4 points right here. They were looking at that and were saying that's only got 4 points. I need y'all to think outside the box. There, I'm gonna dot this up, guys. There's infinitely many little dots, little ordered pairs.
that was right.
So Jameson's group. If I told y'all to list me every X coordinate in those ordered pairs, why would that be a ridiculous task? You're sitting there looking at a bunch of infinite, uncountable amount of ordered pairs. How are they going to list every X coordinate? They're not. So we're going to use an interval. So I know this is the first one we've done together. All I want y'all to do is look at the numbers on the X-axis. This is the farthest that circle goes to the left. Does anybody disagree with that?
No.
That is as far to the left as your circle goes. So what X value is that? Just this group up here?
4.
It's 0.
So let's start with the left. Guys,
Oh, we starting with the left.
we are. The furthest that graph goes to the left is 0. All right, Abram, I think you answered this one already. How far to the right does it go?
4.
And I agree. Guys, domain is just that simple. All you do, and I'm going to write it over here to the side. I just want to zoom in. Domain, I'm just going to put capital D. It is literally 0 to 4. Guys, that is not an ordered pair. That is an interval. The reason is, we got to wrap our minds around this. There's infinitely many ordered pairs. That means there's infinitely many X coordinates. But the X coordinates only range from 0, that's an ugly 0, but we're going to go with it, 0 to 4. The X coordinates that are on that circle are strictly from 0 to 4. All right. Y'all see, I don't know, let's do one more.
What about the rank?
We're going to come back to range.
Because of the bracket have anything to do with it?
Does the what?
The bracket that you put around the thing?
Good question. Guys, I'm going to pass it around as y'all participate. Look. Of these infinite ordered pairs, are any of them open circles? None of those, because guys, I know they just did a circle around it, but that connects infinite ordered pairs. None of them are open circles. And you don't need an infinity sign because that circle doesn't go on forever. It stops, it doesn't go any further than 0 to the left and 4 to the right. I'm going to talk to this middle group right here. I want to clarify something with what we study in my class. Let me come back to this one. Guys, look at the U. Y'all studied parabolas before? Look, a parabola is not just open, pointing up. It opens up and out. So why I say that is that right there, that thing's going forever to the left and forever to the right because it's opening outward. Most students would say I don't know what that is. Most students would say that its domain, the furthest it goes to the left, most of them would say that's 1 to -3 to 1 to +3.
But it's infinite.
Those arrows, I know it's pointed up. I get that. But it's pointing up and out. All right? For this next one, when we're going to do the domain, and I'm talking to this group right here, we're going to do the domain for this second graph. What we got to do is, with these arrows, we got to know that it's not pointing straight up. It's pointing up and out. I know I'm not drawing a great connector there, but this thing does get wider over time. So, when we're talking domain, Cam's group, take a wild guess how far left that weird graph continues to go.
Infinite.
It goes on forever to the left.
And forever to the right.
So that what that means is it goes from negative infinity, because it goes forever to the left, to positive infinity. And we always use parentheses for that. You all right, buddy? You gotta stop throwing stuff. Domain. We're gonna stick to domain. We'll come back and knock out range. Let me see. Next group over there. Look at the next graph. I'm talking about this one right here. That whatever shape that is.
It's
Hold on. Let me catch up. Ask yourself how far left on the x-axis does this graph right here go?
-4 to positive infinity.
It helps to number this thing.
-3 to positive infinity.
Alright? Check this out. He said from -3. Why did you say positive infinity to the right?
So that line is going out and it ain't stopping.
That arrow right there means it does go on forever that way.
It ain't stopping.
Slide over to this one. Alright. Miss Bailey's group back here. What about the hexagon I zoomed in on up here? All we care about, because we're doing domain, we want to know how far left, how far right. And look, before y'all answer, guys, if I had this assignment, this little activity do over again, I would have numbered my x-axis. I think it's a great idea for y'all to do that, like 0, -1, -2, -3, -4, -5. If you really numbered all the way there. What's the furthest to the left it goes?
-5.
There's the furthest point.
Oh yeah, -5.
I did number to -7, but if you look, all you're doing is you're trying to see how far to the left the graph goes. This is the easiest way to think about it. Alright, just this group back here, when I'm talking to Bailey's group, how far to the right on the x-axis does that go? Say again?
0.
Absolutely. The furthest it goes to the left is -5. Guys, and if it helps to draw those arrows like I was doing. I'm probably being too honest here. Guys, I've had some really low classes when I've taught this lesson. I'm just being honest. I'm not talking about right now. I'm talking about in the past. What I've had to do some semesters is give them sticky notes and literally put a sticky note over here blocking off everything past the shape or the image to the left. And it would show them that it doesn't go any further to the left than -5. I'd have them tag a sticky note over here that blocked everything off. Guys, and if you ever want to do that, I don't care. I'm not saying you can't do that. You're welcome to do that. But like they would put a sticky note here to block all that off. And all they got to do is look up at the x-axis and it's 0. So that domain is literally, I'm going to zoom out. It's from -5 to 0. Coach Braun's going to take this example. Guys, if I had this to do over again, I would have numbered them. I don't know why I didn't. I don't want to confuse anybody. I'm not trying to be tricky. What were you going to say?
I put brackets around the double quote.
You use brackets unless you see open circles or an infinity sign.
I didn't think we had open and close circles when we moved these.
Always, when you're doing interval notation, you got to use your rules about brackets and whatever. Guys, look right here. I don't want to waste time on this one. I just threw it in here because when you first started learning domain and range, this is how you were presented. A bunch of ordered pairs. So look, you're not going to write this as an interval. Guys, if it was to be an interval, it's got to all be connected. And it's not. So all you do is literally just list those numbers. So I'm going to start with how far left. There's 0, -1, -2, -3, -4. Oh, I don't go to -4. Let's do that again. So there, that should be -3, comma. You're not doing an interval because it's not connected there. It would be -3, -2, -1, 0, 1, 2. I know that's a little weird, but if the points aren't connected, you got to actually list the numbers. You don't do an interval because it's not connected. Look at, I guess number 6, whatever you want to call that. It's array. Mike, Jasmine, Anne Marie over there. If we're doing a domain for this guy,
-2 to positive infinity.
awesome. -2, that's the furthest goes left. And then they said positive infinity because that arrow is pointing forever to the right. Kendon. Working solo today. Kendon, look at the V shape down there in the bottom left-hand corner. How far left and how far right? Start with how far left. How far left on the x-axis does that V shape go? How far to the left does that graph go? Let me tell you what Kendon just did because somebody did this last block. Hold on.
Infinity.
But hang on. Guys, somebody, let me zoom in on it first of all. Somebody last block said the same thing, but they just counted over to -2. But Kendon, why do you think, I heard somebody whisper, but why do you think somebody said negative infinity with that arrow there? We got to imagine it extending on forever. So, the domain there, it does negative infinity to the left. Just Kendon. Kendon, how far right? Nice. Guys, anybody flipping to the back? Don't. I mean, if you really want to, you can. You ain't got to sweat that today. I want to use this front side of this sheet. All right. Don't get confused on this one. Guys, I just put something silly on here. Don't treat those, I mean, they are open circles, I guess, technically, but I just did a smiley face. We won't study smiley faces. You're still just answering anybody. I'll take anybody. How far left, how far right? Go.
3 left and 3 right.
So -3 because you went left.
Yeah, and then 3 right. And then it's in brackets, but they're all close circles.
Yep, Nate, you're right, man. You're spot on.
No.
Did not mean to close all that. Please still be there. Okay. Guys, I did domain just all the way through. You could have easily done domain and range. We'll come back. The range. Let me clear.
Is it range how high? Oh, it's like range number 2 would be negative infinity and positive infinity.
Guys, this is all the notes you got. Let's just come back and touch up the range. I'm gonna ask y'all to participate here too. Look at the range. Range is Y values. That's how far down, how far up. That's the easiest way in the world to think about it. Everybody, let everybody do the same one you did. Jameson, y'all's group. Y'all take the range for that first circle. Just ask yourself, hey, let me say this while y'all are looking at it. The only time you'll ever look at the y-axis is with range. That will be super important on Monday and Tuesday. The only time you ever need to read me a number off that y-axis is with the range. That's it. Everything else is all about the x-axis. So this first group up here, how far down does that graph go on the y-axis?
0.
All right. Because the lowest point down here, it doesn't go any lower than 0. And then how far up?
4.
Guys, if it helps you to number them like I'm doing up there on my screen, number them. It don't get any higher than 4. Excellent job. Tell me if I'm moving too fast, because on the screen, like I know people are writing, I'll always go back. Cam, didn't I give y'all this one?
Mm-hmm.
So this middle group, ask yourself how far down? Just the middle group. Say it louder. All right. Hey, and again, guys, if Coach Ron was more consistent, if I was more consistent, I would tell you to do this every time. You don't really have to do this every time. But positive infinity, negative infinity on the x-axis. It's also helpful to remind yourself positive infinity's up top, negative infinity's down below on the y-axis. So I asked how far down. Brianna said infinity. Just call it negative infinity. No harm, no foul. And then how far up? Y'all's group. Positive infinity. So I need to scroll back. Let me know. Who do I have for this one? Who was that did this one? Y'all?
It's -3 to +4.
That's gonna be hang on, let me catch up. Austin's group.
-3
So-
to +4.
Say one more time.
-3 to +4.
There's -1, -2, -3. Let me zoom in for y'all. It goes down to -3. And what's the highest it goes on the y-axis?
+4.
Would you put a bracket there because it cuts over? Like since it just keeps going up?
Stick to your rules. Yeah. Only use a parenthesis with infinities and an open circle. And you don't have any open circles here to worry about. This was Trent's group back here. Let's look at the y-axis. Just ask yourself for that hexagon, how far down does it go? Nobody answer, and y'all don't answer immediately. Let's look at it first. What's the lowest it goes on that y-axis? And look what I'm doing up there on the screen. It helps if you'll just number. Now for sure, what's the lowest that it goes?
-7.
Count again.
-8. Oh, wait, the lowest is -1. I was like, no.
I'm talking about the hexagon. You're good. I'm talking about the hexagon. The absolute lowest it goes there is what for sure? Just this group? For sure. -6 is the absolute lowest it goes.
Yeah,
You
he
did?
said that. That's why I can't.
I didn't say anybody was right or wrong. I didn't say anybody was wrong. So Andre, what is the highest it goes? For sure. Nice.
I like it.
Coach Ron,
Yes.
does it matter how we put them in there?
Say again.
Like, what if we put in -2 and then -6? Would that be wrong?
Always put the smaller number first. That's why I said how far left, how far right, and then how far down, how far up. That'll keep you in line if you'll do it in that order every time. Let me speed this up. Range here. Guys, again, on the one where just a bunch of ordered pairs, best we can do is just list them. The best we can do is just list them. -1, 0, 1, 2, 3, 4. So starting at -1, we would just -1, 0, 1, 2, 3, 4. I think, Mike, this was y'all's group, right?
-2 positive pairs.
All right, hang on before you answer. Y'all had this one?
No.
Y'all didn't?
Oh, it is?
So you got the domain. Y'all gave me the domain.
-1, 0.
I know why you say that. Guys, this one's a little weird. The domain, they did perfect. All right, look at the range here. So, Mike, how far down does that graph go? -1. Does it go any higher than that? This is a weird one. Guys, every ordered, you don't have to write this, but every ordered pair on that, that's -2, -1. That's -1, -1. Your Y value will always be -1.
Put -1, -1.
There's one single number there. This was Kendon. Kendon, how far down does your V shape go there? -2. How far up does it go, Kendon? Nice. And anybody, let's take this last one and be done. That's it for notes. Guys, all you do when you come back, don't worry about the back side. What I've got when you come back for your groups, I got a little card sort where you're gonna match graphs to the domains. But what about what's the range on this last one? Yes, sir.
-3 to +3 within brackets because they're all filled in.
It goes down to -3 and it goes up to +3.